But did you have any kind of thoughts or anything that you wanted to add from your time at Black Hat? You might not be on the webinar right now. It's all right. I'll ask him later. But let's see. Is are Phalgun and Julia on? Yes, they are. Okay, awesome. So I'm going to go ahead and hand it over to you guys. Like I said, Simonor was the first woman that we had present at VeloCon, and now we're going to have our second woman present, Julia Paluch. I hope I'm pronouncing that name correctly, who is also going to be here with Phalgun Kulkarni. I think they're going to do like a tag team, if I'm not mistaken. So just to give you a quick rundown on Phalgun and Julia. Phalgun, and they both of them, by the way, come to us from Aon. Phalgun Kulkarni is a DFIR consultant at Aon. In this role, he has gained a wealth of experience investigating cybercrime cases with expertise in memory analysis, malware reverse engineering, and host-based analysis. Phalgun has helped numerous organizations effectively respond to cyber threats and safeguard their assets. He holds GXFA, GCFA, and GCFE certifications. And then Julia is a DFIR software developer at Aon. She has experience investigating business email compromise, insider threats, APT intrusions, and of course, ransomware. Julia enjoys finding ways to automate her work, contributing to internal tools, and having jam sessions with her friends. Julia holds a GCFE and GCFA certification. So Julia, I'm interested to know what instrument do you play and can we jam together?
Thanks for the question. I play bass guitar and I'd love to jam with you.
Awesome. We'll have to set that up sometime. All right, I'm going to stop my share. I'm going to hand it over to you guys. The floor is yours.
Awesome. Thanks, Carlos. Thank you all for coming to our talk today. We really appreciate it. Phalgun and I are really excited to share our research. Today, we're going to be talking about the Windows Search Index because we believe that it's the forensic artifact you've been searching for. So as soon as Phalgun gets these slides up, we can get started.
Yeah, thank you so much for joining. Just give me a minute to get things set up.
I will say if there's one thing Zoom has to improve on, it's the slide handoff process during these webinars. It's not exactly the cleanest.
There's too many apps. Like we're used to WebEx and Slack. We don't really use Zoom that much.
And you guys have some extra time too. So if you guys want to kind of let it go and go into a little bit more detail than you otherwise would have, please feel free.
Awesome, thank you. All right. I think we're good to go. Okay. So yeah, once again, thanks everyone for coming. We're really excited to give this talk with you. So let's get started.
Right. Hi all, I'm Phalgun Kulkarni and I work at Aon delivering Strauss Friedberg's incident response and digital forensic services. And in my role, I work on multiple cyber incidents such as ransomware, threat hunts, and APTs. And I love to come up with novel ideas and perform research to improve DFIR as a whole.
And I'm Julia. I'm a software developer. I focus on DFIR and threat intel. And I work closely with Phalgun and the rest of the DFIR team to help build tools that make their jobs a little bit easier. And if you're not familiar with Strauss Friedberg, we work on a wide variety of cases. We work on everything ranging from large APT intrusions and ransomwares to small business email compromise cases and purely digital forensics cases for individuals. We're lucky to be part of a really talented team, and we're also lucky to be able to perform the kinds of research that we're here presenting to you today.
Right, so why should you listen to us? We have been researching Windows Search Index thoroughly, and we have a good understanding of this artifact. We were amazed by the wealth of information we could recover just from a single artifact. We wanted to share those insights with you to help you enhance DFIR investigations. So by the end of this talk, you will be able to understand how Windows Search Index can help you answer questions associated with files and folders on a disk, metadata related to non-existing files, as well as historical activity related to a user's internet browsing activity. So let's get started by setting the agenda for this talk. We begin by introducing Windows Search Index and how it works. We talk about how the database is structured and what data is stored in the Windows Search Index database. We quickly introduce changes introduced to Windows Search Index in Windows 11 operating system. Next, the most interesting part, and I'm sure you're going to love this one, which is the forensic value held by Windows Search Index artifact. And last but definitely not the least, we showcase velocider, Velociraptor plugin to parse Windows Search Index efficiently and at scale. So before we move on, I wanted to take a minute and explain what a forensic artifact is. So Windows operating system introduces features which are aimed toward enhancing user experience. So let's say, for example, jump lists can allow a user to switch between multiple files quickly, and prefetch can shorten the startup time taken by any application or program. But on the flip side, jump lists can also be used to prove file knowledge as well as file access, and prefetch can be used to determine whether a program or an application was executed or not. So similarly, Windows Search Index exists on a system for users to be able to search for multiple files, but then it can also be used as a forensic artifact. So let's get to know more about Windows Search Index.
Okay. So with that paradigm in mind, let's talk a little bit about how Microsoft typically markets this, the Windows Search Index to the average consumer. So the way that Microsoft wants you to use the search index is to use it as the search bar that you can get by pressing on the Windows key on your device. You can use the search bar to search across files on your system. You can use it to search across your web history, and you can also use it to search the web. Different apps will also implement the search index in other ways. So for example, Microsoft Photos will use the index to track changes to your files. If you are searching for a message that you maybe drafted last week and you don't remember where you put it, you can use the Outlook search bar, which on the back end is also using the Windows search index to search through the messages on your device. Cortana also uses the search index to provide search results, and there are many other apps in the Microsoft Store that will implement the search index in other ways. So let's talk about how this actually looks in practice. So let's say you created an invoice last week and you forgot where you put it, but you remember what it's called. So you search the search bar for invoice.xlsx. And then the search box is going to query the Windows Search Index that exists as a database on disk. Before all this happens, the Windows Search Service is periodically extracting information from files and index locations, and it's cataloging that information in the Windows Search Index. So the Windows Search Index will find the record of that file, and it will tell you, hey, your invoice is in your documents folder, and you will be eternally grateful for how helpful the Windows Search Index is.
All right, now that we know how Windows Search Index works, let's get to know what data is stored and how it's structured in the database. So basically, files and folders from two directories, namely C users and start menu programs, will be indexed in a database. Now, there is one exception here. Files and folders from app data directory will be excluded by default. And this database can be found at C program data, Microsoft, search, data, applications, Windows directory. So let's see how this database looks like. Beginning from Windows Vista until Windows 10, the database sits in an extensible storage engine format, and the database is named windows.edb. An important point to note here is the Windows Search Index service will be enabled by default only on the Windows endpoint operating systems and not on the Windows Server operating systems. Windows.edb file contains a lot of tables, but we have identified 3 to be the most useful ones. They are system index gather, gather path, and property store table. Now, property store table is one of the most important tables, and we will be referencing it a lot in the further slides. And if you want to know more about these tables, we also have a blog post, which we will be referencing in the end slides, and you can always refer the blog post for more details on these tables. So let's get to know how windows.edb file looks like. When viewed with Nearsoft's ESE database view, we can see that all the ducks are in a row, meaning that each entry or each record will have a separate row, and every column represents a unique file property. But let's consider an example here. Let's say you are in a DFIR engagement and you are analyzing a Windows 11 operating system. Now you want to parse Windows Search Index and you go search for windows.edb file, but you couldn't find one. You ask why? Because Microsoft introduced changes to Windows Search Index in Windows 11 operating system. So now the windows.edb file is split into 3 SQLite database files, namely Windows Gather DB, Windows DB, and Windows USNDB. Windows USNDB is still being tested upon and is out of the scope of this presentation. So basically, all the data remains the same, but the format is changed from ESE to SQLite. So let's quickly compare how the changes in Windows 10 and Windows 11 looks like. As we can see on the left-hand side, in Windows 10 or in Windows EDB file, all the tables are in a single database. But in Windows 11 or Windows Gather DB, we can see that system index gather and gather path are split, and they are stored in the Windows Gather DB database. And importantly, the property store table is now split into 2, namely property store and property store metadata. And these tables are stored in the file name windows.db. So let's quickly take a look at how windows.db file would look like. We use DB browser for SQLite to view the windows.db file. And as we can see, all the ducks are not in a row now. So every record or every entry will have multiple rows, and we can see in the property store table, the work ID column represents a unique record or unique entry. And the column ID column represents values which can be mapped to their respective file properties in the property store metadata table. So let's consider an example here. In the property store table, let's take row 1, and we can see that the column ID value is 13. So when we map that value to the property store metadata table, we can observe that 13 represents system is folder. So that's how we know work ID 1 or record or entry with work ID 1 is a folder. And similarly, we can map the rest of the file properties to their respective values from the property store and the property store metadata table. Julia, if you're speaking, you're on mute.
I'm sorry, I couldn't unmute. It like the mute button like just disappeared. I'm so sorry. All right, let me go back. I kind of spoiled the surprise for you all. That's okay. So since Phalgun was talking about how the Windows 10 database the Windows 10 database exists as an ESE database, unlike the Windows 11 index database, I want to give you a quick note about ESE databases in particular, because they can be a little bit difficult to work with, especially in a DFIR investigation scenario. So let's talk about why. ESE databases, or extensible storage engine databases, were made specifically for many near simultaneous transactions, or in other words, many database reads and writes happening nearly at the same time. What this means is that they can be dirty or in an inconsistent state because all those reads and writes are happening so close to each other. But the way that this database deals with that is by a mechanism that I am about to describe to you. So in a perfect world, a file would be created, and then the record of that file is immediately added to the search index databases. But like a lot of other databases, in the case of an ESE database, it doesn't work that way. And instead, when the file is created, a record is immediately added to a log buffer, which exists in memory. And that log buffer is pretty small. So once it gets full, the log file will be written to disk. However, if you experience a catastrophic shutdown, or if you perform a live image of a system, those log files may not be written to the database, which will result in a dirty database. And the reason why this is a problem is because a lot of the tools that we use in DFIR are relying on the fact that the database is in a clean state. So either if you run one of those tools on a dirty database, you'll either get inaccurate results because you haven't replayed those logs to the database, or you may not be able to parse it at all and the tool will just crash. Thankfully, however, there is a built-in Windows tool called ESCNT util, and that's going to help you perform recovery, replay those logs to the database, and then repair it if it's damaged or corrupted. So I want to bring your attention to two commands in particular. /R is going to do that recovery and replay those logs, and then /P is going to perform that repair. There's a couple caveats to this tool. The first one is that you have to run it on an operating system that's equal to or newer than the one where the windows.edb or any ESE database came from. So if you're, for some reason, using a Windows 7 system to perform forensic analysis on a Windows 10 search index database, you're not going to be able to clean it because the Windows 7 ESE engine is just not going to be able to handle this newer version of the ESE database. The second caveat here is that some of you are probably catching on to this, but these log files will also contain record deletions. So if you're doing a true, deep dive into a system, I would recommend analyzing both the dirty database and the clean database, because you're going to get those records in the dirty version that you wouldn't get in the clean version if they're deleted. So if you're not able to parse the dirty database, you can just run the repair without doing the recovery for that first version. Okay, so I feel like that was kind of dense and technical, but hopefully this next part of our talk will be a little bit more interesting. Now we're going to talk about the forensic value of the search index and some use cases. So first, let's talk about the file and folder enumeration feature of the search index, and specifically what it can tell us about files and folders that exist on the system. So just to recap, whenever a file or folder is created in an index location, that file record is placed into the search index database. And that file record is going to include a lot of metadata, a lot of really useful metadata, including the full path of the file, MAC timestamps of the file, different file attributes like the file type and the file owner, as well as index gather time, which is the time at which the record was either created or subsequently updated. So let's talk about where this information might be useful. If you are familiar with incident response engagements, you might know that threat actors like to drop malware and stage files in subfolders of C users, so any user folders. Thanks to the search index, you can enumerate those files that exist in C users star. If you are investigating a user that may have wittingly or unwittingly downloaded malware or some sort of malicious files, those files are likely going to end up in their downloads folder. And thankfully, you can also enumerate that folder using the search index. Next, again, if you're familiar with IR engagements, you might know that threat actors like to create malicious startup tasks to gain persistence on a system. And those startup tasks will likely end up in this start menu programs startup folder, which is also indexed by the search index. So you can enumerate them there as well. Lastly, if you're investigating a rogue employee who's maybe created or deleted files that are important to an investigation, we'll talk a little bit more in depth about this later, but you may be able to enumerate deleted files using the search index. And some of you may be wondering, like, why does any of this matter if I have access to the system, right? If I can see the files on the system and the search index is just telling me what I already know. Well, what if you have a triage collection of the system and you don't actually have all the user files? You can use the search index along with other artifacts like the MFT to prove existence of files on the system without actually having access to those files. Okay, so let's move on to another feature of the search index that is really helpful for DFIR, and that feature is auto summary. Auto summary records partial file contents, and you may be thinking, like, this is the perfect feature for DFIR investigators. How can this not have been made specifically for us? Well, the reason that this exists is that so that users can search for a file using the file contents. So if you don't remember what you named a file, but you remember what you typed into the file, you can search for it using the search bar or the file explorer. So in this example, I hid the word pineapple in this search_test.txt file, and I was able to search for it by searching for my keyword in File Explorer. One caveat of auto summary is that the file extension has to match the file type in order for auto summary to record the contents of the file. What this means is that auto summary is using a file extension to understand how to parse the contents of the file. So if you have a plain text file and you save it as a .pdf file, auto summary is going to expect to have to parse a PDF, and it's not going to be able to record the contents of your plain text file. One thing that Phalgun and I observed in our research is that in Windows 11, up to the first 1024 bytes of a file may be recorded. And some of you are probably realizing this means that if the file is small enough, you may be able to get the full contents of the file. So let's talk about what files actually have their contents indexed, because it's not all of them. And I'm not going to read out this list to you, but there are some that may be sticking out. For example, if you're hunting for web shells in an IR engagement, .asp files have their file content captured by the search index. So you'll be able to view any sorts of IOCs that appear in that file just by looking at the search index. If you're dealing with a threat actor who is using .bat, .cmd, or .vbs malware, you'll be able to view the contents of those files in the search index as well. Lastly, if you're investigating a maybe an insider threat for maybe a corporate client, or maybe it's a internal matter, you may want to focus more on Office files like Excel files, docx, PowerPoint files, anything of the sort. And thankfully, the Windows Search Index is also capturing the file contents of those files as well. And lastly, I know that you're all on the edge of your seats wondering, like, can the Windows Search Index help me recover deleted files or any information about deleted files, or maybe contents of deleted files? And like many things in DFIR, the answer is it depends. In our testing was a little inconclusive, but we did observe that if we performed a live forensic image of a system, we were more likely to view file records and they were more likely to persist in the database. However, if we performed a system shutdown or reboot, we were less likely to view those deleted files. However, we did achieve some success recovering those file records using this specific tool called WinSearchDB Analyzer. Even though our testing was inconclusive, the thing that you should take away from this is that if you have access to the Windows search index, parse it anyway and see, because maybe you can recover some deleted files or even deleted file contents from the index.
Awesome. Thanks, Julia, for walking us through one interesting aspect of Windows Search Index. And now let's take a look at another important aspect. So at times, investigators may need to discover a user's internet browsing activity, but they may not have the browsing artifacts at their disposal, or they may want to cross-verify their findings. So Windows Search Index can help in that as well. Windows Search Index will index activity conducted using Edge and internet browsers. One caveat here is that activity conducted using private browsing mode will not be indexed. So in Windows 10 or in Windows EDB file, interestingly, the successfully accessed URLs will be stored in the item path display column of the property store table. Again, the most important table. And unsuccessfully visited URLs, meaning that if the URL did not exist, let's say, for example, 123 this website does not exist.com, or if the URL was visited without an active internet connection, then those type of accesses will be stored in either activity content URI or activity description columns of the property store table. In contrast, in Windows 11, we observe that irrespective of how you visit a URL, all the visited URLs will be stored in the system link target URL column of the property store metadata table. A quick caveat here is that we observe some of the unsuccessfully visited URLs may not be present in either windows.db or windows.edb files. So now that we know Windows Search Index can also enumerate internet browsing activity, the question has to arise, what if a user deletes their internet browsing activity? Windows Search Index might save your day. So we tested by deleting the browsing activity from the browser itself, as well as by deleting the app data folder of Edge browser. And interestingly, we were able to recover the entire history or the entire session with the URL being visited, the type of the access, as well as when it was visited. Now, how amazing is this information? Like, you don't even need to have any browsing artifacts at your disposal, and you will still get the historical as well as current internet browsing activity. But in contrast, in Windows 10 or in Windows EDB file, we found out that deleted browsing activity may sometimes be present in the database, but not most of the times. An important point to note here is internet browsing activity can also be present in the activity history feature of Windows Search Index. Now, you may wonder, what is activity history? So let's talk about it. Windows Search Index can also tell you when a user interacted with a file and using which application or program. So activity history feature will track file interaction per user. And importantly, if a file was renamed or if it's deleted, which is not existing on a disk anymore, and if that particular file was interacted with in some point at a time, then that activity will still be present in the activity history records or entries. So that's one way you can enumerate interactions regarding non-existing files. Isn't this cool? And the way you identify activity history records is by enumerating the system item type column in the property store table and looking for activity history item string in that column. One important point I wanted to mention is activity history is a subset of the entire user activity. So if an activity is not present in this feature, it doesn't mean that it did not happen. And again, like we mentioned previously, some of the internet browsing activity may also be present in the activity history feature of Windows Search Index. And remember, so let's get to know what exactly gets indexed. So let me give you an example here. Let's say I interacted with a PDF file using Firefox browser. Now, the full path of that PDF file, including my SID or security identifier, the start and end times, which also correspond to the opening and closing time of the activity, as well as the program used in the interaction. And in this example, Firefox browser will be indexed in the activity history feature. One quick caveat: the start and end times of activity history may sometimes differ by a few seconds, so they may not be the most accurate timestamps at times. And remember, I mentioned that activity history is a subset of entire user activity. So you may wonder what exactly or what activity is indexed in this activity history feature. So we tested by interacting with few common file types. If, for example, we interacted with text format files using commonly used applications like Notepad, WordPad. We interacted with PDF files using most commonly used browsers, as well as Adobe Acrobat Reader, and our day-to-day files like Excel, document, PowerPoints, and photos. So that activity will be indexed in the activity history feature. Another important aspect of Windows Search Index is that it will also store data related to Outlook and emails, but that is out of the scope of this presentation.
All right, so let's talk about how this actually looks in practice. How does this look if we actually create a file and view the record for it in the search index? Okay, so we created a malicious looking file, and you can tell that it's malicious because there is an IP address in it. And then we viewed the Windows search index. So first we viewed the activity history. We wanted to see if we could view the file contents. And since it was a small file, we were able to view the entire file contents as well as that super scary looking IP address. And then we viewed some of the other attributes. So from the search index, we were able to view our activity history. So we had the full path of the file that included the user SID. We also had the app display name, or the program that we used to open the file. We had the file name as well as the activity history start and end times, which corresponded to the times that we opened and closed the file.
All right, now let's get to know about velocider. So velocider is a velociraptor artifact which uses CIDR, or Search Index Database Reporter, to parse Windows Search Index at scale. It will parse both Windows 10 and 11 database files. And in the artifact, we have set CIDR's URL to include the latest version or release. So you don't have to change the URL every time we release a new version of CIDR. So let's get to know CIDR in more depth.
Okay, so let's first talk about why our team created CIDR in the first place. During our testing, Phalgun and I observed that though the GUI-based tools are really helpful, it's difficult to load multiple indexes at the same time for the purposes of comparison, which is what we really needed for our research. So our team created a command line tool that you can use to parse multiple indexes at the same time. So some features of this tool include the fact that you can parse both ESE and SQLite databases in the same execution of the program. So you can have a folder that contains both windows.edb and windows.db files. And just by running CIDR once, you can get output for all of them. It provides readable output of the search index. So it provides 3 different reports, and you can get them in either JSON or CSV format, whichever you prefer. It's really fast, so it enables parsing of the index for maybe a time-sensitive matter that you're working. One of the reasons that it's super fast is that it's written in portable Rust. It's open source on GitHub, so if you're so inclined, you can test out the tool and create issues or open up PRs. It's under Apache 2.0 license, and if you don't feel like compiling it on your system, you can download a Windows build from GitHub. So how do you use it? So first you call Cider, and then you give it some options. So you give it the format. You can either do JSON or CSV, but it is JSON by default if you don't provide the format argument. You give it an output directory. So this is wherever you want your reports to land. If you don't provide it by default, they will land in your current working directory. You can ask for help, which will print this help message, and then you can get the version of the tool. And then you give it a path to your input directory. And I just want to emphasize that this is not the path to the actual database, but it's a path to the directory where multiple, or maybe multiple databases will reside. And that directory will be recursively scanned. So you don't need to have them all at the top level of the directory. So let's see it in action. Like I said, you call Cider, you give it an output directory, as well as a format, and then you give it the path to the input directory. And as you see below, you will get 3 different reports. In this case, we have CSV reports, and the way that they're named is that you'll get the host name of the system, which will help if you're working with multiple different systems. It will help you differentiate the reports. You will also get the type of report, and then you'll get the date and time of execution of the tool. And last but not least, like I said, Cider is really fast. And in order to showcase this, Phalgun and I created this monster directory of many windows.edb and windows.db files. And it was nearly 6 gigabytes worth. And Cider was able to parse all of them in under 22 seconds. So yeah, we're proud to say that it's a very fast tool.
Right. Thank you, Julia, for introducing us to such an amazing tool. Now that we know how Cider works, let's get to know how VeloCider works. So we begin by creating a copy of the original or live Windows search index database on the target machine to a temporary database. Now we do this because Cider will need a database to parse and generate results. And as the live or the original database is locked by the operating system, Cider won't be able to execute it. So that's the reason we create a temporary database and execute Cider on that. Next, we pull the latest release of Cider from our GitHub repository and then execute Cider on the temporary database. Now, importantly, these operations will only happen if and only if the size of the database is less than 2 gigabytes and the free space in C drive is more than 5 times the size of the database or Windows search index database. You may wonder why these conditions. Let me tell you why. So Windows search index at times can get very big in size. So let's say if we are dealing with a 10 gigabytes of database and we create a copy of that 10 gigabytes database, we are utilizing 10 gigabytes of free space or unused space in C drive. Now that free or unused space may have some forensic evidence which may be valuable for your investigations. So that's the reason we have capped it at 2 gigabytes and check for free space in C drive to be more than 5 times the size of database so that we don't consume all the free space or like exceed or go beyond the free space which is available in the C drive. And I would like to invite you to read the description, the conditions, as well as the warning which are placed in the artifact before you use the plugin, because this is crucial for you to know how VeloCider works and what effect it may have on the target endpoint. So let's get to know results generated by velocider. Let's talk about the preparation and execution phase. As you can see, we will be able to observe which database was parsed, the full path of the temporary database, and if the database was in a dirty state, velocider will prompt you a warning. It will also provide you with instructions on how you can clean or recover the database. Once Cider executes itself on the database, it will produce 3 beautiful CSV reports. So let's talk about the files and folders report. You will be able to enumerate all the files and folders present in the database or which are indexed from the mentioned locations. Next, we have the Internet History Report, which will show you information about a user's internet browsing activity. And lastly, for the reports, we have Activity History Report, mentioning activity or interactions regarding existing as well as non-existing files. So how amazing is this information? And given the fact that you just need to click few buttons and all the information is available to you from just a single artifact. You don't need to extract the useful data from a large data set. It's already done for you. And I think this will save you a lot of time in the time-sensitive matters like Julia mentioned. Next, for velocider, we have 2 options or parameters. So first one is upload results. If you check this option, it will upload the CSV reports generated by Cider to the Velociraptor server. And this is how it will look like. So you get the full path of the report being uploaded and the system from where it's coming or where it is generated. Next, we have the collect Windows search index database option. So let's say for some reason you want to have a raw database, and if Cider for the given conditions did not parse the database, you have the option to collect the Windows search index database on the Velociraptor server. And this is how it will look like when you upload a particular file or all the files related to Windows search index database. You get the full path of the file as well as the system from which it is coming. So let's quickly see a demonstration of velocider. We begin by searching for Cider. And as you can see, we have a beautiful description, how velocider works, the conditions which are put in place, as well as the warning, which I invite you to read before you use this artifact, because that is crucial. Let's see configuring parameters. Like I mentioned previously, you get 2 options. First one is upload results, that will upload the CSV files generated by Cider if for some reason you wanted the raw CSV files. Next, we have the collect Windows search index database option, and that will collect the database or all the related files if you want to clean a dirty database or if you want to have a raw database for parsing it on the forensic tower. And you can use Cider itself to parse this database. So let's launch this artifact and see or take a look at the results generated by Cider. So first, we start with the preparation and execution phase. Like we mentioned previously, you will get the full path of the database being parsed. And if it is in dirty state, you will get a prompt as well as instructions on how you can clean that dirty database. And in this case, you can use the collect Windows search option to upload the files. And you also get the full path of the reports being generated by Cider. So let's take a look at files and folders report. Like I mentioned, you will be able to list all the files present in the database. Next, let's take a look at Internet History Report, showing all the browsing activity conducted by various users. Next, we have the Activity History Report, mentioning file interactions associated with current as well as non-existing files. So isn't this amazing and pretty cool? All you need to do is click few buttons and the beautiful CSV reports will be available to you on your Velociraptor console. All right, now that we know how velocider works, let's get to know some use cases of how Windows Search Index can help you in DFIR investigations. So you can even uncover a heist. If you are investigating a rogue employee, you will be able to enumerate the full path of the file in question, as well as partial or full content. And in this case, we know someone bought private jets and Lamborghinis. Man, I want Lamborghinis. Next, we have the activity history report, which can show you file interactions per user. We can also enumerate the activity start and end times, the program used to interact with the file or application, and the name of the file itself. Velocider can even show you internet browsing activity. And for those who search their crime online, we will be able to catch them. Like we can observe, we will be able to see the title of the web page and when it was accessed, as well as full path of the URL which was accessed. Next, we can also enumerate initial attack vector or access vector. So sometimes employees may download legitimate looking files, but then in actuality or reality, they will be malware planted by threat actors. We also call this drive-by compromise. And if that's the case, Velocider can show you internet history report and you can enumerate that activity as well. Next, if there is anti-forensics in question, and if a threat actor is really noob and Googles how to do anti-forensics, we will be able to discover that as well. Sometimes exfiltration can be difficult to identify. We have observed that threat browsers to visit the exfil site, and that's how we can enumerate if there was any data exfiltration in place or in DFIR engagements. And remember how we mentioned that you can even enumerate deleted file interactions. So we tested by creating a file, interacted with it, and hard deleted the file, meaning that file did not exist on the disk, and it was also not present in the files and folders report. But interestingly, we can see that we can enumerate the file name, when it was interacted with, the program used to interact with the file, as well as the user who interacted with the file. So isn't this information pretty cool? You get so many details about the file which is not existing on the disk anymore.
Thanks, Phalgun, for that look into Velocider and what sort of information you can get from those different reports. That is kind of the bulk of the technical part of our talk. I hope you enjoyed learning more about the Windows Search Index, and hopefully you will use it in your next investigation. So I just want to give you all some key takeaways that you can get, that you can take away from our talk today. So like we said, you can enumerate file and folder existence using the index, as well as you can also view partial file contents. You can view user activity using the index as well, which can provide file knowledge as well as important timestamps that tie to maybe activity of a suspicious user. Lastly, you can also get internet history, even deleted internet history, using the Windows Search Index, which you can use to also enumerate another part of a user's activity.
And why should you use Velocider? Because why not? It's fast and easy to use Velociraptor artifact, which can parse both Windows 10 and 11 databases. So you don't have to parse them one by one. It can also show you analysis, or it can also show you important aspect of Windows Search Index, and it can really save you time in time-sensitive matters. Importantly, you get information which you can straight away take and make useful or insightful data from that information. And you can get your velocider plugin today. To scan the code, it will take you to our GitHub repository, and that's where you can find the YAML file, which you can use to create a new artifact in your Velociraptor console. We promise it's not a phishing attempt.
And if you weren't taking meticulous notes, or if you fell asleep, then that's okay. We also have a blog post where we have all the information that we presented to you today, specifically about the search index as an artifact. So we also break down some more technical aspects of the actual database structure. So if you don't want to scan that QR code, we also have the hard link there at the bottom. And if you're on Twitter, go ahead and follow us. We're at Straws DFIR. We'll be regularly posting our thought leadership on that account.
I wanted to thank few people who helped us during our research. Partha Alvar and Carly Battle for helping us throughout the research and developing slides, and Oleg Dolgov, Vitali Reshituk for developing Cider in such a short amount of time. And lastly, I wanted to mention that our research was based on version 22H2 of Windows 10 and 11 operating systems, and Velociraptor version 0.6.9. We do encourage you to perform your own research, but it may differ based on the build numbers. So thank you so much for joining us, and we are open to questions now.
Phalgun and Julia, thank you so much. That was awesome. If you're just, I encourage you guys to read through the chat. There's just some amazing comments in there based on your presentation. You guys also have a few questions in the Q&A. If you want to start to address some of those. If anybody else has any questions for Julia or Phalgun, please pop them into the Q&A chat box. I see there's a few really interesting questions already in there. So really, you can tell there's a lot of engagement with this presentation. So thank you guys. Phalgun, we're going to see you again after lunch.
Yes, sir.
For the other presentation that you're helping out with. But until then, thank you very much. Julia, thank you so much. We're going to give everyone a little time back. I originally had put 12:30 on the agenda as the time that we would start lunch. But I think we'll start a little bit early now. Let's reconvene back at 1 o'clock. So that gives everybody 40 minutes to grab a bite to eat, or depending on where you are in the world, a cup of tea or even breakfast. So please hurry back at 1 o'clock. We'll get started with the next presentation. Thanks, everyone.
I would like to address the questions.
Oh, yeah. But before we go, why don't you address some of those questions now, Phalgun?
Yeah. Robert Weibner, sorry if I butchered that name, but yeah. If Cider does not parse the database due to the conditions put in place, you are able to upload that database. But I would like to highlight that database can get very big in size, so that may cause an issue to Velociraptor server itself. But that won't stop you from uploading the database to the Velociraptor server, irrespective of whether Cider parses it or not. You can even copy the original database. You don't need to create a temporary database. So that's a functionality Velociraptor will provide to you. If that answers your question. So go ahead, Julia.
I was just gonna address Hilko Bengen's question about configuring the Windows search index to store different types of files, maybe the ones that aren't stored by default. I don't quote me on this. I believe you can go into advanced options of the Windows search index and customize what is indexed. So you can actually add other index locations. And then I believe you can also change the settings so that those different file types also have their content captured. I encourage you to test on your own system. If you can do that, I would like test right now live, but I'm on a Mac. But I can test on a Windows machine and get back to you later. But the Windows search index feature is highly customizable. When we were giving this talk at another conference, somebody asked, like, can a user turn the search index service off? Like, yes, they can, because it's a highly customizable feature of Windows. And they also, the databases themselves take up a lot of space. So you can certainly customize them to maybe minimize what's actually indexed. But that's a great question. And I'll try to confirm that and get back to you.
Eric asked, how does the search function work in regard to other browsers such as Chrome? So by default, Microsoft will only index the default or built-in browsers like Edge or Internet Explorer, not record any data browsers like Chrome, Firefox, Brave, etc. Jakes Jansen also mentioned that, is it worth running the EC2 commands in Velociraptor before examining the file? Like Julia mentioned, it depends, and we would encourage or recommend to parse both the dirty as well as the clean version. And we would recommend you to create a copy of a database before you clean it. So that will be on your forensic tower in an ideal situation.
All right. I think that's all the questions in the Q&A. I mean, Phalgun and I, you can reach us. We can reach out to us on LinkedIn as well if you have any other questions, or maybe if you have questions for Phalgun later. You know, we can get back to you at a later time for anything that we need to confirm. But yeah, thank you everyone for listening.
Thank you so much, all.
Thanks again, Julia and Phalgun.
Bye.
All right, folks. Once again, we'll reconvene at 1 o'clock Eastern time.